Hey everybody, BTO Pro here. Today we're going to cover another basic element that I've transitioned from Polymer to LitElement. Kind of look through what some of that process looks like in our tooling as part of an ongoing series where I'm just kind of showing some of the elements that we have. So what I've pulled up here is on webcomponents.org. If you search for hexagon, you get this hexagon loader. Now, we love some hexagons on projects associated with Elm's Learning Network and hacks. So decided to just make a very basic tag, and all this tag does is it supplies you with a hexagon. And then it has the loading capability. So the loader then takes that and makes this nice little transition thing. And so it gives you a super basic API, right? You can say loading, and if it's in a loading state, then it bubbles, and if loading is turned off, then it'll go away. You can also say how many there are, some basic color settings and sizing settings. Right, so this forms the basis of a really basic API so that we can have this nice clean hexagon loader of all different configurations. We use this in parts of hacks with the little 4 dots usually. So let's look at what that looks like historically. So in our mono repo, which is LRN Web Components, and go to Elements and then Hexagon Loader. And hexagon-loader.js, and we've got a Polymer element. It's got a very basic template, right? And then we've got, somewhere down here, the ever wretched DOM repeat. So, love it or hate it, DOM repeat is an amazing tag for what it's applied to the Polymer universe. It would basically take an array and loop through it and print things based on it. So imagine this is a for loop, more or less, but it's happening in the DOM. So how do we convert that to LitElement? Because that's a little bit more sophisticated a process. So I'll go to CD Elements and then Hexagon within my LRN Web Components thing. And then I'm going to do yarn start, just like we do with the rest of our elements. So it'll think for a second, fire up our documentation. While that's loading, this is where I am in the repo for this. So looking at package.json, you can see we've now got LitElement, yay, LitElement. But this is one of our full-blown elements using our tooling. So we've got our JavaScript split out from our HTML, our CSS, and even our properties. So what this LitElement ends up looking like in our tooling, and actually I'm going to clean that up, get rid of the word Polymer, yay, is we can see that there's a section that says this is required for tooling, do not touch, and it literally, if I get rid of that, this whole thing will break. It's because there's a watch directory going on right now that's looking at my HTML file, my CSS file, which I get to then get nice color coding and work on independently, and then it's compiling them in real time into this, right? So there's my styles block, there's my render function, and it's got that pushed in there. It also does it with properties too. So these are my properties coming from its standalone properties JSON file. Now this won't validate as valid JSON because of the way that it's going to be pushed into a JS file. But ignoring that for a second, you can see the properties we have for this element. We reflect our color, we reflect our size, we reflect loading, and we have items as an array, and then we've got item count. Important note, item count here is camel case, so we can use it as a JavaScript variable. But to pull it in from the outside, via, to go from HTML and map it to this property from the attribute, you need to say what attribute in HTML that is using that. So if we look at the HTML, we'll get this weird function. So we've been able to get rid of DOM repeat, yay, and instead replace it with just a map. So if you're not familiar with map, this is a new capability in JavaScript. New, it's several years old, but if you've been doing jQuery for a while, this is unfamiliar to you because it was to me until recently. So reading this as a human would, this is template literal syntax, and it's going to stamp into it this.items.map, which means run through each item in the array and do the following. So then the following is going to be render HTML, and it's going to be hexagon. So this does the exact same thing as the DOM repeat, but is way faster than the DOM repeat could ever have dreamt of being. So it's a wonderful replacement. And that's all we have for the HTML to do this. Our CSS, we've got some host selectors with those reflected attributes, right? So this is how we do our sizing. You see I'm just doing some basic transforms on the scale. That way the spacing is all relatively the same. I've also got a hexagon tag in the lib directory, and the hexagon tag is, let's export this to the bottom. I don't like to do it at the top. The hexagon tag is a vanilla HTML element. So glancing at that for a second, you can see that we've got some styles. We've got a CSS variable that can be pulled in here. We define our tag, which that's not part of the spec, but I just love to do. Life cycle for our vanilla element. Then we create the guts of the element and the template. I don't actually use this queue anywhere, so I can actually, here's some more code I can get rid of in going back and reviewing some of these original elements we did. Yay, so I got rid of the word queue everywhere because we never actually implemented that. So you can see that we create a template, we attach a shadow root, and then so long as we're not delaying rendering, which I never do, then we're going to call the render function. And our render function in this vanilla JavaScript element, get rid of that thing too, we don't use that, is saying, hey, nullify the shadow root, look at, or set the inner guts of the template tag to the HTML in question, which you can see at the top, there's that get HTML. So then we can do support shady CSS and prepare the template if that's around, which helps with polyfills, legacy browsers, some interesting little conventions in different browsers. So then we do shadow root.append child, and it's going to clone that HTML template. So effectively, this is creating the shadow root for our element. This is the way you could do this in vanilla JavaScript without using any of these other libraries. So what you get as a result of this, see there's a single div. I mentioned it was simple. And then with that div, I target it to turn it into the hexagon. So this is one hexagon as a little tag. Then, look in our HTML, right? We're running through a map and we're just printing a bunch of hexagons. So then that's what we'll do the loading sequence. And then the magic comes in with the JavaScript. So in LitElement, in your constructor, you have to set default values. So, and I've been trying to do a better job of documenting these. This is vanilla JavaScript lifecycle. Whenever you're using a vanilla convention, I'm trying to get better at saying it's vanilla versus saying something is specifically a LitElement lifecycle. So default value 37. I just happen to know that 37 hexagons makes a really big meta hexagon. And so you can see I set a default value on items to be just an empty array. And then we've got the updated lifecycle hook, which is updated is monitoring changes in your properties and then letting you run functions off of them. So two things. One is color changed. This is a convention that I borrowed, lifted, whatever you want to say, from Polymer. Polymer had this .update styles method, which basically just said if shady CSS is around, run this shady CSS styling of the subtree, meaning the element in question. So this allows you to dynamically set a color value to this hexagon color CSS variable. So you're kind of mapping from JavaScript into CSS rather dynamically here. So tracing what is happening here when we get to our demo. So the initial demo just says hexagon loading. And in fact, I can take that loading off and we'll see that when I go to the loader, right? So this is the locally running equivalent of that demo from before that was on webcomponents.org. You see there's nothing loading there, or claiming to be loading, because I took that flag off. So we'll put loading back on. We get our 37 wonderful loading sequence thing. And it's 37 because of my default value. Whoops, didn't want to print, I wanted to inspect. So we pull that up, we'll see there's 37. The absolute wonderful magic of LitElement is, let's take that to 20 or 10. It's just how stinking fast that is with re-rendering all of these. I think 37 is like the max that I actually allow because of this just the way that this little grid works. So there we go, 34. These are loading. You can see it's kind of chunked them because I'm not getting rid of all of them. I think if I were to take this down to 1 and then took it up to 37, that they would all be in sync visually. Oh, except that one. Now, that won't happen when it initially loads. It's just because of the way that this is rebinding. But you can see right there, if you're familiar with DOM repeat would have taken all of these out and then put all of them back down based on this array mutation, whereas this is only taking out the ones in question. And I know it's only taking out the ones in question because you see that visuals, right? These get out of sync, and that's because it's only re-rendering these ones. It's pretty awesome to be able to see that in real time. So looking at these demos then, right, I have item count 4, size small or large, right? And so those values are passed down correctly into the different elements to ensure that those are sized appropriately. Then in the HTML with a map, the way that that works is, I'm kind of abusing this here, but so I have 37 as the items, and then items itself is blank. However, when this loops through, right, it's a map of the items. So I need an array of something for this to stamp down. I can't just say run yourself 37 times. So the way I do that is whenever item count changes, then I nullify this.items, and then I loop through the item count, so in this case it would be 37, and then just push a blank value into the items array. So if I was to console.log this.items, and we'll do that down here, we'll see just a big old mess of empty arrays if this works right. There we go, 37. So it then loops through 37 times. It's just using it to basically stamp things multiple times there. So I hope this is a useful look inside the guts of, even something as basic as a loader here, and trying to ensure that you don't have these massive dependency trees just for something that on the page is ultimately, it's a stupid hexagon. So it was very important to me to have the hexagon itself be a vanilla JavaScript element, right? I don't need a dependency tree for a dumb hexagon to load there. But when you start to get into, okay, well, I'm going to render that hexagon all over the place, that starts to get a little more sophisticated. I need a little bit more logic. And then LitElement comes in with its property binding to really just make it so simple to do that I wouldn't want to do it otherwise. So if this is interesting to you, the hexagon-loader, any of the elements that we work on are available on GitHub. A big old monorepo under the organization Elms LN /LRN Web Components. And if you're interested in anything more about why the heck we're even building any of this, you can check out hackstheweb.org to learn about all the many web components that you're going to see featured in these videos. Ta-ta!